All right, how's everybody doing?
Hanging in there. How you doing, Nick?
Oh, pretty good, thanks. All right, so I got PA5 graded last night. Posted grades and comments and feedback. So really, really nice job on PA5, everybody. Um, Had a bunch of hundreds, which is awesome. And most people were able to get a maximum value function coded that worked correctly. And that was really the primary goal of PA5, is being able to find a solution to the knapsack problem, right? So getting a maximum value. Um, the whole assignment was really kind of three separate tasks, and the first and sort of central task is the max val function itself. And I'll run through some sample code in a little bit, but again, most people were able to get max val working. The second task is, keeping track of the count of items that get you the given maximum value. And as we've said, in previous classes, that's sort of a separate step. That's a step that can be tackled once you've got the integer solution coming back. And it's a housekeeping question. It's a matter of keeping track of item counts and passing those around. So your code becomes a little more complex. Instead of returning integers, you have to return a structure. Instead of initializing a max val to 0, you also have to initialize an item count array to 0, and so on. And then once your function is working, then there's the dynamic programming, which is adding a cache to save your answers to avoid repeated recursions. And that's really, adding one thing in the beginning, one thing at the end of your function. So if you get all three of those pieces working, right, then you're online for getting 100% on the assignment. But if you didn't, right, that's okay. I would say the most important thing I want people to get out of this was a closer understanding of recursion. And I heard from some students, that this really kind of helped recursion click for them. And that's really the goal. We want to be very comfortable with this concept of writing a solution to a problem that involves using that thing we're writing in order to get the solution. It's a wonderful technique. It's something that will pop up a lot in 223 in Java, and it kind of leads our mind into sort of the mindset for object-oriented programming. So that was the main thing, and then the second thing is dynamic programming, which, as we went through yesterday, is really just add something in the beginning and something at the end to cache values. So let me know if you have any questions on my feedback, and we can certainly talk about it. But let me go through some sample code, and this is my attempt at a solution to PA5. And again, it's not magic code. It's just an example of a way to do this. So let's see. So it's nice to use defines, and there's lots of stuff in here you were not required to do, right? So I'm going through this as just an example of different ways to do things. So one thing that's nice to do is to avoid magic numbers, right? So I said that you can assume there's no more than 128 items in your inventory, which means some of your loops only have to go up to 127, your arrays only have to be declared to hold 128 things, and so on. But the number 128 might pop up, 5, 10 different places in your code. It might appear in different files and so on and so forth. If you wanted to change that and allow, 256 items, you would have to go through and find all those 128s or 127s and change them accordingly. So if you instead define a symbol, so here I'm calling max num items as a symbol for 128, and I use that instead of the number 128. Now if I want to change my inventory size to 256, all I got to do is change this. Right? So that's just, something if you feel like you're using magic numbers, you can define a symbol. And this is what null, N-U-L-L, is. This is what EOF is. They're things that are defined in standard I.O. So that we don't have to say, 0 or -1 when we mean null or end of file. So I define two symbols, maximum capacity, which I set to 1 plus the maximum capacity, just for various reasons, and number of items. And since I want to write a max val function that returns not just a maximum value, but an inventory of items, I have a structure that I called answer that basically has two pieces. So the maximum value itself, and then the array of how many items you need to get that maximum value. And this is the structure we talked about in class. So in this array, item I is an integer which tells you how many of item I you should put in your bag to get this max val. My cache, which I just called save, is just an array of answers. And if my maximum capacity is 1024, I need to be able to access elements up to 1024, which means that this array has to be declared at least 1025 in length, unless you adjust, by -1 or something. So that's why this is 1025 for a max cap of 1024. So this can store elements from 0 up to and including element 1024. And I preset element 0 to be all zeros, item counts of 0, max val of 0, so that if I need to return a 0 from somewhere, I can just return element 0 from my cache. So that's just kind of dual purposing. This is the structure for my inventory. So most people had something like this, right? We have a weight and a value for each item, and we have a name, and we're going to make an array of these that we read in the contents of from our file. The super exciting function prototypes, which I won't talk about. Main program. So here's the inventory that we're going to read from the file. And it's an array, and in C, arrays don't have a built-in length, so I have a separate integer called inventory length, right? For me, this is what I do if I have an array named x. I'll have a variable called xlen, which will tell me how long this array is. And that's not a policy, but that's almost always how I deal with arrays when I need to know the length. It's a habit. So I don't have to think about it too hard. Answer is just a temporary. So then there's all of this command line processing. So first, make sure you've got 3 arguments. If you don't, print a usage message, tell the user how they should be running the program, and exit. I use fprintfs to standard error here. So we touched on this a little in 224, but basically there's 2 output streams that you always have available in Unix. There's standard out, which is what printf writes to, but there's also standard error, which you can write to by saying, file printf, and then naming your stream and saying standard error. So what's the difference? Well, they both appear on your screen. Right? If I run this and I get an error, I'll see this printed out on my screen, just as if I had said printf. The difference is if you redirect your output with a greater than sign or a pipe, these things that go to standard error will still appear on your screen. So it's a way to help ensure that the person running this code actually sees this message, even if they're sending the output into a file to look at later. So pretty typical when code generates an error message when you get a compile error from C, for example. Instead of going to standard out, it goes to standard error. So this is one way to do that. So if the argument count's wrong, print a usage message. If the argument count is correct, they put in the program name, a capacity, and an item file. Let's see if the capacity is legal. So I use scanf. argv bracket 1 will be the capacity. So scan that as an integer, save the result in cap. And cap does not tell me if I succeeded in parsing. The return value from scanf tells me. And if this is an integer, then scanf will return 1. So if scanf does not return 1, they didn't type in a good integer. So again, I give them a usage message, and then I just exit. And returning from the main program exits. Okay, they typed in 3 things on the command line. The second thing was a valid integer. Is it a legal capacity? So if it's less than or equal to 0 or exceeds maximum capacity, print an error message, exit. So that's all testing, the user specification of what they want done. And then initialize my cache. So I did that in a function called init. Read in the items from the file. So the file name is this third argument, which is in argv2. So let's read that from our inventory from that file. And I pass it the array I want to save the items in, and this function I set to return the number of items it reads. And if it returns 0, it means something went wrong. It couldn't open the file, there was a badly formed line inside, something. So if the inventory length that comes back is 0, I'll print an error message and I'll exit. Alright, otherwise I'll go ahead and call this echo function, which basically just prints out the inventory that you get to choose from. And then I call maxval to get the answer. And then I print the answer, and that's it. That's my main program. So the main program is pretty short, right? Other than checking the usage, right? This is main. And it doesn't actually do anything, right? Except call a bunch of functions. And from a top-down mindset, that's really what main is. It's a thing that calls a bunch of functions that do the actual work. And this is really, input, processing, output. I've got a little output here too. But you can think of many programs as basically input, process, output. All right, so this main program is really easy for me to work with. It's a holder for, what I want to do, but of course you have to write all these functions like init and read inventory and echo and of course maxval. But the other advantage of this is, I can write my init function, I can call it right here, I can say, exit at this point, I can comment out all of this. And I can go into the debugger and I can check my save array after I call init and make sure that's working correctly. I can do the same thing with read inventory. So this is one way to modularize your code, to break it into modules or blocks, right? And this is what's typically called a top-down approach. You assume that you have all these lower level functions and you start by writing the higher level functions. In this case, the main program. All right, so maxval is the workhorse. This is the one that does, the actual calculation of the maximum value. And this part is the piece that we kept talking about in class, right? That main loop where we go through and we say, which item should we put in our bag first? All right, so let's talk about that quickly. Basically, inventory length is the number of items that I have to choose from. So I go from 0 to inventory length minus 1. And let's see if that bag can hold that item. So if the weight of that item is less than or equal to the capacity, then we're going to go ahead and we're going to say what happens if we put that in our bag. So if we put it in our bag, the capacity of the bag gets reduced. It gets diminished by the weight of that item. So I create a diminished capacity variable. That's the capacity after I put the item in. And I call max value. And I say, hey, how much value can I get out of this smaller bag? And I save the answer in temp answer. And temp answer tells me the maximum value and the count of items that get me that value. But in this pass through my for loop, I'm assuming I'm starting by putting one of item I into my bag. That's why I reduce the capacity. So I increment the count of item I in my temp answers list. And I increment the max value in temp answer by the value of item I. So now at this point, temp answer is the situation if I start by putting item I in my bag. It has the final maximum value and the complete count of how many of each item goes in my bag to get that max value. So now I just want to know, is this a better solution than what I've seen? Well, I initialized max to -1 up here, so the first time I do this, I'll definitely get a better answer, even if it's 0. Right? So if this is better than my max, save my max so that I know what my new maximum is, and save my entire answer in this local variable called max answer. It's just a local. And iterate across all the possible items in my bag. Alright, when I'm done, assuming that I've ever executed this code, max answer should be my best solution. But that's only going to happen if I execute this code at least once. And it's possible that all of my items weigh more than my bag can hold. Like my capacity is down to 1 and all my items weigh at least 3. So I check my variable that I set outside here to -1. That's a flag to see if I actually put anything in my bag. If I didn't, I'll just return a 0. So element 0 of my cache was the special value that just has a 0 in it. Otherwise, we found a best answer called max answer. Alright, so the dynamic programming part, we talked about this the other day, right? It's two things. One, in the very beginning, before all of this, check your cache. See if you've saved something. So I initialize max value to -1 in my cache. And so if the max value is not negative, it must have been saved somewhere. And so I just return that, and that's it. I exit my max val function right here. But the first time I calculate max val for a capacity, I have to do all of this work. And then at the very end, before I return, save my answer in the cache. And then the next time that you call max val for the same capacity, this will say, oh, I already know the answer, and it'll return immediately. So that goes in the beginning, this goes at the end. Everything else is the same, even if you're not doing dynamic programming. So that's the max val function. And that's kind of the workhorse of the whole thing. And pretty much everybody got this part working, except possibly for the item counts. Right? And if you don't worry about the item counts, then you don't have to increment the number of items and copy those over and so on. Alright, the details aren't particularly interesting, so I'll just run through them really quickly. So reading the inventory from the file, right? Open the file. If it returns something less than or equal to 0, that's an error. And I don't print anything here. I return an error by returning a 0. Right? This is supposed to tell me how many things I read from the inventory file. If it returns 0, main is going to treat that as an error condition, and it will print a message and exit. Otherwise, loop while you read in lines from the file. Try to convert to 2 integers in the name. If the conversion fails, I'll print a message so that there's a format error. I'll show you the string that was containing the error, and I'll return my flag of 0 so that main exits. Otherwise, count items, bump up your inventory length, and if it's bigger than the maximum number of allowed items, print an error message saying the inventory is too big, and return that error code. So iterate over that. If you come to the end of the file successfully, close your file, and then return the inventory length. Initialize is just going through my cache, setting my max vals to -1 to tell me that I haven't stored a value yet. Setting the maximum items to 0, I don't think, yeah, that's necessary too. I don't think that's necessary. That'll get updated, but it's cleaner to me to put that in there. So, and then setting max val 0 to be 0, so I can use that anytime I want to return a 0. Echo is just a loop over your items that prints out the contents of the inventory with some headers. And then print answer, if the max val is 0, we didn't find a solution. Otherwise, print out the solution and then loop through and print out all the items that have at least one of them in the bag. So there's always multiple ways to code anything like this. This is a fairly lengthy implementation in terms of, I didn't need to store this in a separate variable, because the only thing I do with diminished capacity is I pass it as an argument right here. That's the only time it gets used. So why not just do cap minus inventory I dot weight right here? That's probably what I would normally do. But I wanted to put this on a separate line so that I could, have a comment saying this is a new capacity. If I had a problem, I could stop right here and print out diminished capacity, or I could put a print statement in my code, right? So this is deliberately breaking things into, doing one step per line instead of combining things. But, in practice, a lot of this would probably get glommed together. And somebody asked in the earlier section about commenting, about level of commenting, and I didn't take off points for commenting, but I saw really good commenting on people's code this time. I don't want to budget points for commenting and coding style. I want that to be something that's fairly natural for you, and that you just do out of habit. When you're writing code, at least for a class or for somebody else. So, I don't have a comment block in the beginning of my print answer function saying it takes 4 inputs and here's what the inputs are and here's what it does, right? This just prints the final answer. And to me, if I look at this, it's pretty clear what these arguments are. This is the answer that I want to print. This was my inventory. This was the length of the inventory. When you're writing code for a different class, or on a job, or for a customer that you're doing work for hire, there may be specific requirements. You may be required to document your functions in a way that lists inputs and outputs and side effects and so on. When we start working with Java in Spring, right, there's ways to create those kinds of function headers automatically. There's a utility called JavaDoc, and if we're working in an IDE like Eclipse, we can have outlines for those function header blocks created for us automatically. Right? So I wanted you to do that in those last few assignments, just to get some practice and exposure to that kind of thing if you've never done it. But we're not always going to do that ourselves, right? So here, I'm showing the breakdown of how you get that maximum answer. I don't have any comments on these lines of code. I don't really need them, right? If I understand C, I understand that this is only going to happen if this item list bracket I is not 0. If you have no idea what answer is and what answer.item list bracket I is, then a comment here might help, saying, we don't have any of item I in our answer. But that's kind of what this says. So there's, this idea of self-documenting code. And it's a valid concept up to a point. Some people can write, 1,000 lines of code with, double pointers and all kinds of stuff, and to them it's obvious what the code does, right? But is it self-documenting to somebody else? So continue to explore, level of commenting. I think if you find a level that's useful for you, that's probably a pretty good benchmark. Now, you'll find teachers who say, you have to comment like this, or teachers who say, never comment like that, right? But hopefully, if anything, people have been putting in more comments than they need up to this point, and feel free to back down a little bit from that, to modulate around that, to increase it. But try to find a level that makes sense to you. And I know a lot of people still comment as the very last step, but try to get in the habit of commenting while you write your code. So WSUV, you do a lot of C, you do a lot of Python, and you'll do some Java. And you'll do a lot of it in Unix. And it really depends what courses you take, but like 360 will be a lot of C programming. So you'll definitely get to do all this stuff a lot more, and you'll go to a much deeper level on some of these things. Let's see. What is challenging is to work with people who believe their code is self-documenting. In reality, it's only self-documenting in their mind. Yeah, exactly. So, when you're in the thick of coding something, it's really clear to you what's going on, right? You know exactly why you're saying, pointer star this thing arrow that is equal to, this big long algebraic expression, right? You understand that really well. But yeah, come back after a while, come back in a month, and see if it still makes sense. So it's an ongoing discovery. And I'm going to tend to be a little less draconian about commenting going forward, unless people get really sloppy, right? If I start getting code that's like all left justified with no comments anywhere, then I'll probably start, putting that on the grading rubric. But explore it. Find a style and a level that makes sense for you, and have fun with it. I always put song lyrics in my music when I was an undergrad. People put poetry into their comments. I love making ASCII art, right? I'll draw pictures using ASCII characters to help explain what's going on in a piece of code. Yeah, C art, exactly. And that's all part of the creative expression. And at the bottom level, right, programming is to me a creative exercise. It's an art form. And if you're being hired to and paid to write a program that does some particular thing, it's got to do that particular thing, right? But that doesn't mean that it's not a creative form of expression. And one way you can exercise that expression is in your commenting and your coding style, right? Unless there's a style guide you're subject to. And just kind of the general way that you structure code, that's part of your expression. So yeah, someone commented in chat they took a break from their SLP for a few days and then had to kind of reverse engineer their code. This happens all the time, right? I don't know how many decades it was before I really got into good, solid coding habits. Actually, it probably wasn't a decade. It was probably a few years where I kept going back and having to reverse engineer what I had done because it wasn't commented well enough. I thought it was. Yeah, someone just posted this in chat. So there's a good program that probably does something useful, but be kind of fun to go back and try to read. I don't know what this actually does. I'll have to compile it. On the other hand, there's periodically places that have contests for the most can't say the word obfuscated, most confusingly written program to do some simple task, and that's another art form in itself, right? Trying to write code that looks like a picture itself and actually runs and does something. And at assembly language, right, this becomes even more important. Um, because assembly language, we don't necessarily have, you know, clear function names and variable names. And if you're writing machine code, and I've actually considered having people do machine code um, as a way to explain why commenting can be useful. Um, yeah, it's definitely useful. All right. Any other questions, comments, reflections? Assembly language is arguably human readable. So, if we do pick assembly language, increment file register count, decrement file register time, branch if not zero, loop. Right, so that's assembly language. It's not as high level as C. Each of these is, a single instruction for the CPU. Machine code is just the binary or the hex representation of binary. Right, it's really just the ones and zeros. And it's the version that's pre-digested for the CPU. It's the version that gets loaded into memory and the CPU can directly read it and decode it and execute it. Whereas this, if a CPU fetches an I and an N and a C, it generally doesn't know what to do with that. This has to be converted into that. So this is machine code or binary code. This is assembly language. Yep, ones and zeros. Assembly is simultaneously the most and least abstract language. Yeah, that's a cool way to look at it. And commenting assembly language, right, really kind of forces you to think about, why am I writing a comment? If I put a comment here which says increment count, that's a kind of useless comment. Because if you don't know assembly language, you're not looking at this code. And if you do know the assembly language, this says increment count. So putting a comment which says increment count or set count equal to count plus 1 really doesn't add any value to somebody looking at your code. Here, decrement time. Decrement time, well, that's not an informative variable. Branch if not zero, loop. If not zero, go back to loop. Well, that doesn't really tell you anything more than this. So the only commenting you can do when you're at this level is describing what a block of code does, right? So count down till timer expires and record number of ticks required. Might be a block of comments before this set of code. So if you've done 270, you may know what I'm talking about. If you haven't, if you're doing 270 this summer, this will make more sense. How would you send zeros and ones without some instructions? Where do you inject something like that? Oh, that gets into a loader. So assembly language programming, right? You're writing something like this. You're running it through a program like GCC. On Unix, it would be called AS. And it turns it into a bunch of ones and zeros that go into a file. But those ones and zeros have to somehow get injected into the memory of the computer, and the CPU needs to be told to start executing those. And that's a task that's usually called something like a loader. So like on an Arduino processor, there's a bootloader where you basically send in these ones and zeros through a serial port connection, and it loads them into memory. On Unix, we would basically have these things sitting in a file with a name like ls or date or cat or vi or gcc, and there's a command we can use, a function we can call named exec, which says open up this file, read the ones and zeros, load them into memory, and then start executing that effectively. Sometimes those loaders are provided by the manufacturer, but a lot of times they're just kind of developed because, say, an Intel processor can be used in a lot of different systems. It can be used in Windows, Linux, OS X. It can be used um, for something, completely different. Um, but the operating system usually includes some way to load code into memory and have it executed. Let's see. Yeah, this is a good comment. So someone said, I think it's better to comment each line rather than blocks, but instead of commenting what's literally happening, you need to be more big picture. So the comment would explain why you're incrementing count. Yeah. So that's really good good guidance. So you can explain, keep track of number of iterations, count down remaining time until the timer has expired. Things like that. But you're always after, more than just what does this line of code do. Just like when we say, if x equals 0, return, right? Saying return when x equals 0 doesn't tell you why you wrote that, right? If an error occurred, exit this function, right? It might tell you something more. All right, so if you do 270 in summer, we'll play around with this. This is all really good stuff. But 223, we're going in the opposite direction. We're going to move from C into Java, and it's moving away from the assembly language or machine language level of things, and it's a lot of fun. All right, but before that, we got a final exam to do. So let me talk a little about the final exam. We'll talk more about this tomorrow. But let's start it today. So first of all, your final exam is on Wednesday, and it's from 11 o'clock to 12:50. All right, and you got to take it during those times. It's not something you can take, any time during the day. You can't take the Monday exam. Wednesday, 11 o'clock. I again recommend being in Zoom. You can mute the sound if you like, but keep a chat window open just in case there's clarifications, typos in the exam, something I need to specify, and so on. Those will get dispensed through Zoom. If you're not in Zoom, I don't have any way to get that information to you, and you might end up, trying to solve a problem that's really, really hard because there was a mistake in how I wrote the problem, right? And I might have meant to say, oh, you can assume such and such, and it makes the problem a lot easier to do. So I recommend logging into Zoom, staying logged in for the duration. And the exam will be a PDF file that you download, just like the midterm. It'll be a PDF you download from Canvas. You write up the exam yourself, type it up, turn it into a PDF, submit that through Canvas by the deadline. Okay, section B, 11 o'clock to 12:50. You got to have your submission in by 12:50, and there'll be some horrifying penalty for every minute it's late again, just to make sure that people get it in by the deadline. But Canvas will not automatically lock it out. Canvas will not give you a countdown. So you got to keep an eye on the time and make sure you get it turned in. And I'll be in Zoom the whole time, so I'll send you out, a reminder when you got like 5 minutes left. I'll let you know, and so on. And the exam will be cumulative. It covers everything potentially back to the beginning of this course, but with a bit of a heavier emphasis on the stuff since the midterm. So mainly since the midterm, we've been doing trees and recursion, and those are definitely two big themes. But then there's been other things, heaps and stacks and queues and different kinds of sort algorithms and tries and things like that. So I posted on Canvas a approximate synopsis of what we've been doing. and it may not be all inclusive, but just to kind of give you a hit list. Yeah, I will set it up so that you can submit multiple times. So as you're going, I suggest submitting along the way, just in case, your network connection goes out at 12:40. Well, maybe you can't, spend those last 10 minutes, but you can have credit for everything else that you got turned in. So yeah, you can submit along the way, and I will grade the latest submission that was submitted before the deadline. And you probably don't want to submit something deliberately after the deadline because you lose like 10 points a minute or something. I don't remember. I'll set it up. So basically the same logistics as the midterm, right? So PDF file you download, that'll have the questions, write up your answers, typing them, change it into a PDF, submit that through Canvas as your answers. All right, so I'll start going through the topics here, but I'm going to suggest take a look at this, and if there's particular things you want to talk about tomorrow, we can start with those. Otherwise, I'll just kind of start from the beginning right now and go through in order. Starting with structures. So, I mean, obviously we've been using structures for the entire course, so everybody knows what a structure is and how to access fields. So you'll see some questions about that. Remember, there's a difference between saying, struct node root and struct node star root. If I say struct node root, root is a struct node. If I say struct node star root, root is a pointer to a struct node. And if I make an actual struct node, there's already memory allocated for it. The compiler and the linker set that up for me. But if I say struct node star root, root does not point anywhere yet. And if I try to use the thing that root points to, I'll probably segfault. So that's where we get into using malloc. If you declare a pointer to something, you usually have to follow that with a call to malloc to create space for your structure. Where's the post in Canvas? It should be at the very bottom, right after final exam, the last entry, but please make sure that's accessible because I've got about an 80% success rate posting to 2 sections in Canvas. Oh, good, it's there. Okay, good. I post these to both sections, and about 1 out of 5 times, the second one that I post is inaccessible for some reason, and I have to delete it and repost. Cool. All right, and the main thing on pointers versus non-pointers, right? If we have some kind of struct node root, we can say root.data, root.left, etc. What we usually say is, struct node star something, where this is a pointer to a structure, which means at some point we need to say, what does it point to? And we usually do that by calling malloc, although occasionally we'll set it equal to something else that's pointing to some location in memory. And then here, when we want to get to a field, we use this arrow notation. And this arrow notation means the same thing as this. But don't do this. Right? So I've had a few people who do this in their assignments still, and maybe it's just for fun, or maybe they don't know about this. But if you do this for another teacher, they'll probably ding you, or maybe give you a 0 on the whole assignment, right? You'll almost never see this unless someone's trying to be ironic or confusing or something very unusual is going on. You'll almost always see this notation for dereferencing something that's pointing to a structure. So stick to this, right? And if you don't know how to use this, definitely figure it out, because it will make life a lot easier, in addition to, you know, maybe not getting dinged by another teacher. But it means the same thing as this. It means take the thing that this points to, that should be a structure with a field named data. Give me that field value. All right, and then arrays of structures look just like any other kind of array. We can either say struct node root bracket 10 to make an array of 10 struct nodes, or we could say struct node star pointer bracket 10 to make an array of 10 pointers to struct nodes. Or we could just say struct node star pointer, which also makes pointer an array. Because remember, pointers and arrays are basically the same thing in C. And that's like one of the more confusing things about the language, I think. But this technically is declaring a pointer to a struct node, but it's also declaring an array of struct nodes. And it really depends how you allocate space for this and how you use it. So I could say pointer bracket 0 and access the first element of this array, or I can say pointer arrow, and so on. All right, so so we're out of time here. So tomorrow I'll plan on just kind of going through this, but like I say, look this over ahead of time, and if there's questions you definitely want to talk about, we can talk about those first. Otherwise, it's just going to be listening to me like ramble on about stuff we've been talking about all quarter. So so bring questions to class. Tomorrow's the last day of class. Yes, tomorrow's Friday. So that's the end of the quarter. Your exam will be on Wednesday, and then we are done and ready for 223. So yeah, it's been a fast quarter. All right, have a great afternoon. Enjoy the sunshine if you can. I will see you tomorrow.